Gregorian calendar.
The Gregorian calendar, also called the Western calendar and the Christian calendar, is internationally the most widely used civil calendar. It has been the unofficial global standard for decades, recognized by international institutions such as the United Nations and the Universal Postal Union. The calendar was a refinement in 1582 to the Julian calendar, amounting to a 0.002% correction in the length of the year. The motivation for the reform was to bring the date for the celebration of Easter to the time of the year in which the First Council of Nicaea had agreed upon in 325. Because the celebration of Easter was tied to the spring equinox, the Roman Catholic Church considered this steady drift in the date of Easter undesirable. The reform was adopted initially by the Catholic countries of Europe. Protestants and Eastern Orthodox countries continued to use the traditional Julian calendar and adopted the Gregorian reform after a time, for the sake of convenience in international trade. The last European country to adopt the reform was Greece, in 1923. The Gregorian reform contained two parts: a reform of the Julian calendar as used prior to Pope Gregory XIII's time and a reform of the lunar cycle used by the Church, with the Julian calendar, to calculate the date of Easter. The reform was a modification of a proposal made by Aloysius Lilius. His proposal included reducing the number of leap years in 4 centuries from 100 to 97, by making 3 out of 4 centurial years common instead of leap years. Lilius also produced an original and practical scheme for adjusting the impacts of the moon when calculating the annual date of Easter, solving a long-standing obstacle to calendar reform. The Gregorian reform modified the Julian calendar's scheme of leap years as follows. In addition to the change in the mean length of the calendar year from 365.25 days, 365 days 6 hours, to 365.2425 days, 365 days 5 hours 49 minutes 12 seconds, a reduction of 10 minutes 48 seconds per year, the Gregorian calendar reform also dealt with the accumulated difference between these lengths. Between AD 325, when the First Council of Nicaea was held, and the vernal equinox occurred approximately March 21, and the time of Pope Gregory's bull in 1582, the vernal equinox had moved backward in the calendar, so that in 1582 it occurred about March 11, 10 days earlier than March 21. The Gregorian calendar therefore began by skipping 10 calendar days, to restore March 21 as the date of the vernal equinox. Though not part of the Gregorian calendar itself, the reformed calendar continued the previous year numbering system, Anno Domini, which counts years from the traditional date of the Nativity, originally calculated in the 6th century and in use in much of Europe by the High Middle Ages. This year numbering system, now also called the Common Era, is the predominant international standard today.
Description.
The Gregorian calendar is a solar calendar. A regular Gregorian year consists of 365 days, and in a leap year, an intercalary or leap day is added as February 29, making the year 366 days. Normally a leap year occurs every 4 years, but the Gregorian calendar omits 3 leap days every 400 years, unlike the Julian calendar, which retains those leap days. A Gregorian year is divided into 12 months, as follows. Although the month-length pattern is irregular, it can be calculated with the arithmetic expression L equals 30 plus MOD2 for all but February, where L is the month length and days and M is the month number 1 to 12. For February, M equals 2, subtract 1 from the result during leap years, or subtract 2 from the result during common years. Gregorian years are identified by consecutive year numbers. The cycles repeat completely every 146,097 days, which equals 400 years, and which also happens to be 20,871 7-day weeks. Of these 400 years, 303 are regular years of 365 days and 97 are leap years of 366 days. A calendar mean year is 365 plus 97 over 400 days equals 365.2425 days equals 365 days, 5 hours, 49 minutes and 12 seconds. The same result is obtained by summing the fractional parts implied by the rule, 365 plus 1/4. 1/100th plus 1/400th equals 365 plus 0.25. 0.01 plus 0.0025 equals 365.2425. For a better representation, consider Zellmer's congruence. A calendar date is fully specified by the year, numbered by some scheme beyond the scope of the calendar itself, the month, identified by name or number, and the day of the month, numbered sequentially starting at 1. Although the calendar year runs from January 1 to December 31, at previous times year numbers were based on a different starting point within the calendar. See the history section below.
Lunar calendar.
The Catholic Church maintained a tabular lunar calendar, which was primarily to calculate the date of Easter, and the lunar calendar required reform as well. A perpetual lunar calendar was created, in the sense that 30 different arrangements, lines in the expanded table of Apacts, for lunar months were created. One of the 30 arrangements applies to a century. For this purpose, the century begins with a year divisible by 100. When the arrangement to be used for a given century is communicated, anyone in possession of the tables can find the age of the moon on any date, and calculate the date of Easter.
History. Gregorian reform.
The calendar was a reform in 1582 to the Julian calendar. It was introduced by Pope Gregory XIII, after whom the calendar was named, by papal bull Inter Gravissimus dated February 24, 1582. The motivation for the adjustment was to bring the date for the celebration of Easter to the time of the year in which the First Council of Nicaea had agreed upon in 325. Although a canon of the council specified that all Christians should celebrate Easter on the same day, it took almost 5 centuries before virtually all Christians achieved that objective by adopting the rules of the Church of Alexandria. See Easter for the issues which arose. The Council of Trent approved a plan in 1563 for correcting the calendrical errors, requiring that the date of the vernal equinox be restored to that which it held at the time of the First Council of Nicaea in 325 and that an alteration to the calendar be designed to prevent future drift. This would allow for a more consistent and accurate scheduling of the Feast of Easter. In 1577, a compendium was sent to expert mathematicians outside the Reform Commission for comments. Some of these experts, including Giambattista Benedetti and Giuseppe Melito, believed Easter should be computed from the true motions of the sun and moon, rather than using a tabular method, but these recommendations were not adopted. The reform adopted was a modification of a proposal made by the Calabrian doctor Aloysius Lilius, or Lilio. Lilius's proposal included reducing the number of leap years in 4 centuries from 100 to 97, by making 3 out of 4 centurial years common instead of leap years. This part of the proposal had been suggested before by, among others, Pietro Patati. Lilius also produced an original and practical scheme for adjusting the apacts of the moon when calculating the annual date of Easter, solving a long-standing obstacle to calendar reform. Lilius's proposals had 2 components. Firstly, he proposed a correction to the length of the year. The mean tropical year is 365.24219 days long, while the mean vernal equinox year is 365.2424 days. As the average length of a Julian year is 365.25 days, the Julian year is almost 11 minutes longer than the mean year. The discrepancy results in a drift of about 3 days every 400 years. Lilius's proposal resulted in an average year of 365.2425 days. See accuracy. At the time of Gregory's reform there had already been a drift of 10 days since the Council of Nicaea, resulting in the vernal equinox falling on March 11 instead of the ecclesiastically fixed date of March 21, and if unreformed it would drift further. Lilius proposed that the 10-day drift should be corrected by deleting the Julian leap day on each of its 10 occurrences over a period of 40 years, thereby providing for a gradual return of the equinox to March 21. Lilius's work was expanded upon by Christopher Clavius in a closely argued, 800-page volume. He would later defend his and Lilius's work against detractors. Clavius's opinion was that the correction should take place in one move, and it was this advice which prevailed with Gregory. The second component consisted of an approximation which would provide an accurate yet simple, rule-based calendar. Lilius's formula was a 10-day correction to revert the drift since the Council of Nicaea, and the imposition of a leap day in only 97 years in 400 rather than in 1 year in 4. The proposed rule was that years divisible by 100 would be leap years only if they were divisible by 400 as well. Because the spring equinox was tied to the date of Easter, the Catholic Church considered the seasonal drift in the date of Easter undesirable. The Church of Alexandria celebrated Easter on the Sunday after the 14th day of the moon, computed using the Metonic cycle, that falls on or after the vernal equinox, which they placed on March 21. However, the Church of Rome still regarded March 25 as the equinox, until 342, and used a different cycle to compute the day of the moon. In the Alexandrian system, since the 14th day of the Easter moon could fall at earliest on March 21, its first day could fall no earlier than March 8 and no later than April 5. This meant that Easter varied between March 22 and April 25. In Rome, Easter was not allowed to fall later than April 21, that being the day of the Perilia or birthday of Rome and a pagan festival. The first day of the Easter moon could fall no earlier than March 5 and no later than April 2. Easter was the Sunday after the 15th day of this moon, whose 14th day was allowed to precede the equinox. Where the two systems produced different dates, there was generally a compromise so that both churches were able to celebrate on the same day. By the 10th century all churches, except some on the eastern border of the Byzantine Empire, had adopted the Alexandrian Easter, which still placed the vernal equinox on March 21, although Bede had already noted its drift in 725, it had drifted even further by the 16th century. Worse, the reckoned moon that was used to compute Easter was fixed to the Julian year by a 19-year cycle. That approximation built up an error of 1 day every 310 years, so by the 16th century the lunar calendar was out of phase with the real moon by 4 days. The 19-year cycle used for the lunar calendar was also to be corrected by 1 day every 300 or 400 years, 8 times in 2500 years, along with corrections for the years that are no longer leap years, that is, 1700, 1800, 1900, 2100, etc. In fact, a new method for computing the date of Easter was introduced. Gregory dropped 10 days to bring the calendar back into synchronization with the seasons. Accordingly, when the new calendar was put in use, the error accumulated in the 13th century since the Council of Nicaea was corrected by a deletion of 10 days. The Julian calendar day Thursday 4th October 1582 was followed by the first day of the Gregorian calendar, Friday 15th October 1582, the cycle of weekdays was not affected.
Adoption.
Although Gregory's reform was enacted in the most solemn of forms available to the Church, the bull had no authority beyond the Catholic Church and the Papal States. The changes that he was proposing were changes to the civil calendar, over which he had no authority. They required adoption by the civil authorities in each country to have legal effect. The bull Integravissimus became the law of the Catholic Church in 1582, but it was not recognized by Protestant churches, Orthodox churches, and a few others. Consequently, the days on which Easter and related holidays were celebrated by different Christian churches again diverged.
Adoption in Europe.
4 Catholic countries, Spain, Portugal, the Polish-Lithuanian Commonwealth, and most of Italy, implemented the new calendar on the date specified by the bull, with Julian Thursday 4th October 1582, being followed by Gregorian Friday 15th October 1582. The Spanish and Portuguese colonies adopted the calendar later because of the slowness of communication. Other Catholic countries soon followed. France adopted the new calendar with Sunday 9 December 1582, being followed by Monday 20 December 1582. The Dutch provinces of Brabant, Zeeland and the Staten-Generaal also adopted it on December 25 of that year, the provinces forming the southern Netherlands, modern Belgium, except the Duchy of Brabant on January 1, 1583, and the province of Holland followed on January 12, 1583. Many Protestant countries initially objected to adopting a Catholic innovation. Some Protestants feared the new calendar was part of a plot to return them to the Catholic fold. In the Czech lands, Protestants resisted the calendar imposed by the Habsburg monarchy. In parts of Ireland, Catholic rebels until their defeat in the 9 Years' War kept the new Easter in defiance of the English loyal authorities. Later, Catholics practicing in secret petitioned the Propaganda Fide for dispensation from observing the new calendar, as it signaled their disloyalty. In the 1690s, Ole Roma used his influence to bring about a uniform adoption of the Gregorian calendar in Protestant countries, though that could not be achieved in practice. Denmark, which then included Norway and some Protestant states of Germany, adopted the solar portion of the new calendar with Sunday 18 February 1700, being followed by Monday 1 March 1700. Prussia adopted the Gregorian calendar on the same day. Denmark did not adopt the lunar portion, but decided to calculate the date of Easter astronomically using the instant of the vernal equinox and the full moon according to Kepler's Rudolphine tables of 1627. They finally adopted the lunar portion of the Gregorian calendar in 1776. The remaining provinces of the Dutch Republic also adopted the Gregorian calendar in July 1700, Gelderland, December 1700, Utrecht and Overijssel, and January 1701, Friesland and Groningen. Sweden's relationship with the Gregorian calendar was a difficult one. Sweden started to make the change from the Julian calendar and towards the Gregorian calendar in 1700, but it was decided to make the, then 11-day, adjustment gradually, by excluding the leap days, February 29, from each of 11 successive leap years, 1700 to 1740. In the meantime, the Swedish calendar would be out of step with both the Julian calendar and the Gregorian calendar for 40 years. Also, the difference would not be constant but would change every 4 years. This system had potential for confusion when working out the dates of Swedish events in this 40-year period. To add to the confusion, the system was poorly administered and the leap days that should have been excluded from 1704 and 1708 were not excluded. The Swedish calendar, according to the transition plan, should now have been 8 days behind the Gregorian, but was still in fact 10 days behind. King Charles XII recognized that the gradual change to the new system was not working, and he abandoned it. Rather than proceeding directly to the Gregorian calendar, it was decided to revert to the Julian calendar. This was achieved by introducing the unique date February 30 in 1712, adjusting the discrepancy in the calendars from 10 back to 11 days. Sweden finally adopted the Gregorian calendar in 1753, when Wednesday 17 February, was followed by Thursday 1 March. Since Finland was under Swedish rule at that time, it did the same. Finland's annexation to the Russian Empire did not revert this, since autonomy was granted, but government documents in Finland were dated in both the Julian and Gregorian styles. This practice ended when independence was gained in 1917. Britain and the British Empire, including the eastern part of what is now the United States, adopted the Gregorian calendar in 1752, by which time it was necessary to correct by 11 days. Wednesday 2 September 1752, was followed by Thursday 14 September 1752. Claims that rioters demanded "Give us our 11 days" grew out of a misinterpretation of a painting by William Hogarth. After 1753, the British tax year in Britain continued to operate on the Julian calendar and began on April 5, which was the old-style new tax year of March 25. A 12th skipped Julian leap day in 1800 changed its start to April 6. It was not changed when a 13th Julian leap day was skipped in 1900. So the tax year in the United Kingdom still begins on April 6. In Alaska, the change took place when Friday 6 October 1867, was followed again by Friday 18 October, after the U.S. purchase of Alaska from Russia, which was still on the Julian calendar. Instead of 12 days, only 11 were skipped, and the day of the week was repeated on successive days, because the international date line, although not known by that name in 1867, was shifted from Alaska's eastern to western boundary along with the change to the Gregorian calendar. In Russia the Gregorian calendar was accepted after the October Revolution, so named because it took place in October 1917 in the Julian calendar. On January 24, 1918 the Council of People's Commissars issued a decree that Wednesday 31 January 1918, was to be followed by Thursday 14 February 1918, thus dropping 13 days from the calendar. The Kingdom of Bulgaria changed from Julian to Gregorian calendar during the First World War on March 31, 1916, where the next day was April 14, 1916. Other countries of Eastern Europe, most notably Orthodox countries, adopted the Gregorian calendar in the 1910s or early 1920s. The last country of Eastern Orthodox Europe to adopt the Gregorian calendar was Greece with Wednesday 15 February 1923, being followed by Thursday 1 March 1923. As European powers colonized or otherwise took control of various parts of the world, they generally applied their calendars in those countries. Those countries have generally retained the Gregorian calendars after achieving independence.
Adoption in East Asia.
Japan decided to officially replace its traditional lunisolar calendar with the Gregorian calendar in 1872, so the day following the second day of the 12th month of the 5th year of the Meiji Emperor's rule, became January 1, 1873. The Japanese rendering of the Western months is simply Ikigatsu equals 1 month for January, Nigatsu equals 2 month for February, etc. This brought Japan's calendar in alignment with that of the major Western powers, excluding Russia. To this day, however, it is common to use Nengo, reign names instead of the common era or Anno Domini system, especially for official documents. For instance, Meiji 1 equals 1868. Teshi 1 equals 1912, Showa 1 equals 1926, Heisei 1 equals 1989, and so on. Still, this system has increasingly been replaced in popular usage by the Western calendar, Zai-Li, Seireki, over the course of the 20th century. Korea adopted the Gregorian calendar on January 1, 1895 with the active participation of Yu Kil-chun. Although the new calendar continued to number its months, there were multiple systems used to refer to its years. During the Joseon dynasty, in 1895-97, its years were numbered from the founding of the dynasty, regarding 1392 as year 1. Then between 1897 and 1910, and again from 1948 to 1962, Korean-era names were used for its years. And between 1910 and 1945, when Korea was under Japanese rule, Japanese-era names were used to count the years of the Gregorian calendar used in Korea. In South Korea, from 1945 until 1961, Gregorian calendar years were also counted from the foundation of Gojoseon in 2333 BC, regarded as year 1, the date of the legendary founding of Korea by Dangun, hence these Dangi years were 4278 to 4294. This numbering was informally used with the Korean lunar calendar before 1945 but is only occasionally used today. The Republic of China, ROC, formally adopted the Gregorian calendar at its founding on January 1, 1912, but China soon descended into a period of warlordism with different warlords using different calendars. With the unification of China under the Kuomintang in October 1928, the nationalist government decreed that effective January 1, 1929 the Gregorian calendar would be used. China retained the Chinese traditions of numbering the months and a modified era system, backdating the first year of the ROC to 1912. This system is still in use in Taiwan where the ROC government retains control. Upon its foundation in 1949, the People's Republic of China continued to use the Gregorian calendar with numbered months, but abolished the ROC-era system and adopted Western numbered years.
Adoption by Orthodox churches.
Greece was the last Orthodox country to adopt the Gregorian calendar in March 1923. These adoptions are only for civil or state purposes, and none of the national Orthodox churches have recognized the Gregorian calendar for church or religious purposes. Instead, a revised Julian calendar was proposed in May 1923, which dropped 13 days in 1923 and adopted a different leap year rule. There will be no difference between the two calendars until 2800. The Orthodox churches of Jerusalem, Russia, Serbia, Georgia, Poland, Macedonia and the Greek Old Calendarists did not accept the revised Julian calendar, and continued to celebrate Christmas on December 25 in the Julian calendar, which is January 7 in the Gregorian calendar until 2100. All of the other Eastern churches, the Oriental Orthodox churches, Coptic, Ethiopian, Eritrean, and Syrian, continue to use their own calendars, which usually result in fixed dates being celebrated in accordance with the Julian calendar. This is most interesting in the case of the Syriac Orthodox Church, as one of its patriarchs Ignatius Nemat Allah I was one of the 9 scholars who devised the Gregorian calendar. The Indian Orthodox Church uses the Gregorian calendar along with their autonomous Syriac Orthodox counterparts in India. The Jacobite Syriac Orthodox Church. The Armenian Apostolic Church adopted the Gregorian calendar in 1923, except in the Armenian Patriarchate of Jerusalem, where the old Julian calendar is still in use.
Present situation.
Today, the vast majority of countries use the Gregorian calendar as their sole civil calendar. Countries which have not adopted the Gregorian calendar include Saudi Arabia, Ethiopia, Nepal, Iran and Afghanistan. Some countries use other calendars alongside the Gregorian calendar, including India, Bangladesh, Israel and Burma. And other countries use a modified version of the Gregorian calendar, including Sri Lanka, Cambodia, Thailand, Japan, North Korea and Taiwan. The Gregorian calendar has not been adopted by many religious organizations, which have often retained their own calendars. Alternate calendars are used in many regions of the world today to mark cycles of religious and astrological events.
Timeline.
The date when each country adopted the Gregorian calendar, or an equivalent, is marked against a horizontal timeline. The vertical axis is used for expansion to show separate national names for ease in charting, but otherwise has no significance.
Difference between Gregorian and Julian calendar dates.
Since the introduction of the Gregorian calendar, the difference between Gregorian and Julian calendar dates has increased by 3 days every 4 centuries. All date ranges are inclusive. A more extensive list is available at conversion between Julian and Gregorian calendars. This section always places the intercalary day on February 29 even though it was always obtained by doubling February 24, the bisextum, twice sixth, or bisextile day, until the late Middle Ages. The Gregorian calendar is proleptic before 1582, assumed to exist before 1582. The following equation gives the number of days, actually, dates, that the Gregorian calendar is ahead of the Julian calendar, called the secular difference between the two calendars. A negative difference means the Julian calendar is ahead of the Gregorian calendar. Where is the secular difference? Is the hundreds digits of the year using astronomical year numbering, that is, use, year BC. 1 for BC years. And is integer division of h by 4. This truncates, removes, any decimal fraction, remainder, of the division, for both positive and negative numbers. Thus during the 1900s, 19 quarters equals 4, while during the 500s, 5 quarters equals 1. The calculated difference increases by 1 in a centurial year, a year ending in 2000, at either February 29 Julian or March 1 Gregorian, whichever is later. For positive differences, February 29 Julian is later, whereas for negative differences, March 1 Gregorian is later.
Beginning of the year.
The year used in dates during the Roman Republic and the Roman Empire was the consular year, which began on the day when consuls first entered office, probably May 1 before 222 BC, March 15 from 222 BC and January 1 from 153 BC. The Julian calendar, which began in 45 BC, continued to use January 1 as the first day of the new year. Even though the year used for dates changed, the civil year always displayed its months in the order January through December from the Roman Republican period until the present. During the Middle Ages, under the influence of the Christian Church, many Western European countries moved the start of the year to one of several important Christian festivals: December 25, the Nativity of Jesus; March 25, Annunciation, or Easter, France, while the Byzantine Empire began its year on September 1 and Russia did so on March 1 until 1492 when the year was moved to September 1. In common usage, January 1 was regarded as New Year's Day and celebrated as such, but from the 12th century until 1751 the legal year in England began on March 25, Lady Day. So, for example, the parliamentary record lists the execution of Charles I on January 30 as occurring in 1648, as the year did not end until March 24, although modern histories adjust the start of the year to January 1 and record the execution as occurring in 1649. Most Western European countries changed the start of the year to January 1 before they adopted the Gregorian calendar. For example, Scotland changed the start of the Scottish New Year to January 1 in 1600, this means that 1599 was a short year. England, Ireland and the British colonies changed the start of the year to January 1 in 1752, so 1751 was a short year with only 282 days, though the tax year has stayed as March 25 to this day, being April 6 in the new calendar. Later that year in September the Gregorian calendar was introduced throughout Britain and the British colonies, see the section Adoption. These two reforms were implemented by the Calendar, New Style, Act 1750. In some countries, an official decree or law specified that the start of the year should be January 1. For such countries we can identify a specific year when a 1 January year became the norm. In other countries the customs varied, and the start of the year moved back and forth as fashion and influence from other countries dictated various customs. Neither the papal bull nor its attached canons explicitly fix such a date, though it is implied by two tables of saints' days, one labeled 1582 which ends on December 31, and another for any full year that begins on January 1. It also specifies its impact relative to January 1, in contrast with the Julian calendar, which specified it relative to March 22. These would have been the inevitable result of the above shift in the beginning of the Julian year.
Dual dating.
During the period between 1582, when the first countries adopted the Gregorian calendar, and 1923, when the last European country adopted it, it was often necessary to indicate the date of some event in both the Julian calendar and in the Gregorian calendar. For example, 10/21 February 1750/51, where the dual year accounts for some countries already beginning their numbered year on January 1 while others were still using some other date. Even before 1582, the year sometimes had to be double-dated because of the different beginnings of the year in various countries. Woolley, writing in his biography of John Dee opening round bracket 1527-1608/9, notes that immediately after 1582 English letter writers customarily used two dates on their letters, one OS and one NS.
Old Style and New Style dates.
Old Style, OS, and New Style, NS, are sometimes added to dates to identify which system is used in the British Empire and other countries that did not immediately change. Because the Calendar Act of 1750 altered the start of the year, and also aligned the British calendar with the Gregorian calendar, there is some confusion as to what these terms mean. They can indicate that the start of the Julian year has been adjusted to start on January 1, NS, even though contemporary documents use a different start of year, OS. Or to indicate that a date conforms to the Julian calendar, OS, formerly in use in many countries, rather than the Gregorian calendar, NS.
Proleptic Gregorian calendar.
Extending the Gregorian calendar backwards to dates preceding its official introduction produces a proleptic calendar, which should be used with some caution. For ordinary purposes, The dates of events occurring prior to October 15, 1582 are generally shown as they appeared in the Julian calendar, with the year starting on January 1, and no conversion to their Gregorian equivalents. The Battle of Agincourt is universally known to have been fought on October 25, 1415, which is St. Crispin's Day. Usually, the mapping of new dates onto old dates with a start-of-year adjustment works well with little confusion for events that happened before the introduction of the Gregorian calendar. But for the period between the first introduction of the Gregorian calendar on October 15, 1582 and its introduction in Britain on September 14, 1752, there can be considerable confusion between events in continental Western Europe and in British domains and English-language histories. Events in continental Western Europe are usually reported in English-language histories as happening under the Gregorian calendar. For example, the Battle of Blenheim is always given as August 13, 1704. Confusion occurs when an event affects both. For example, William III of England arrived at Wrexham in England on November 5, 1688, Julian calendar, after setting sail from the Netherlands on November 11, 1688, Gregorian calendar. Shakespeare and Cervantes seemingly died on exactly the same date, April 23, 1616, but Cervantes predeceased Shakespeare by 10 days in real time, as Spain used the Gregorian calendar, but Britain used the Julian calendar. This coincidence encouraged UNESCO to make April 23 the World Book and Copyright Day. Astronomers avoid this ambiguity by the use of the Julian day number. For dates before the year 1, unlike the Proleptic Gregorian calendar used in the International Standard ISO 8601, the traditional Proleptic Gregorian calendar, like the Julian calendar, does not have a year 0 and instead uses the ordinal numbers 1, 2, both for years AD and BC. Thus the traditional timeline is 2 BC, 1 BC, AD 1, and AD 2. ISO 8601 uses astronomical year numbering which includes a year 0 and negative numbers before it. Thus the ISO 8601 timeline is 0001, 0000, 0001, and 0002.
Months of the year.
English speakers sometimes remember the number of days in each month by memorizing a traditional mnemonic verse. For variations and alternate endings, see 30 days hath September. A language-independent alternative used in many countries is to hold up one's two fists with the index knuckle of the left hand against the index knuckle of the right hand. Then, starting with January from the little knuckle of the left hand, count knuckle, space, knuckle, space through the months. A knuckle represents a month of 31 days, and a space represents a short month, a 28 or 29-day February or any 30-day month. The junction between the hands is not counted, so the two index knuckles represent July and August. This method also works by starting the sequence on the right hand's little knuckle, then continuing towards the left. It can also be done using just one hand. After counting the fourth knuckle as July, start again counting the first knuckle as August. A similar mnemonic can be found on a piano keyboard, starting on the key F for January, moving up the keyboard in semitones. The black notes give the short months, the white notes the long ones. The origins of English naming used by the Gregorian calendar. January, Janus, Roman god of gates, doorways, beginnings and endings. February, Februus, Etruscan god of death, Februarius, mensis, Latin for month of purification, rituals. It is said to be a Sabine word, the last month of ancient pre-450 BC Roman calendar. It is related to fever. March, Mars, Roman god of war. April, modern scholars associate the name with an ancient root meaning other, that is the second month of a year beginning in March. May, Maia Maestas, Roman goddess of springtime, warmth, and increase. June, Juno, Roman goddess, wife of Jupiter. July, Julius Caesar, Roman dictator, month was formerly named Quintilis, the fifth month of the calendar of Romulus. Augustus, first Roman emperor, month was formerly named Sextilis, the sixth month of Romulus. September, Septem, Latin for seven, the seventh month of Romulus. October, Octo, Latin for 8, The 8th month of Romulus, November, Novem, Latin for 9, the 9th month of Romulus, December, Decem, Latin for 10, the 10th month of Romulus.
Week.
In conjunction with the system of months there is a system of weeks. A physical or electronic calendar provides conversion from a given date to the weekday, and shows multiple dates for a given weekday and month. Calculating the day of the week is not very simple, because of the irregularities in the Gregorian system. When the Gregorian calendar was adopted by each country, but not Alaska, the weekly cycle continued uninterrupted. For example, in the case of the few countries that adopted the reformed calendar on the date proposed by Gregory XIII for the calendar's adoption, Friday 15 October 1582, the preceding date was Thursday 4 October 1582, Julian calendar. Opinions vary about the numbering of the days of the week. ISO 8601, in common use worldwide, starts with Monday equals 1. Printed monthly calendar grids list Mondays in the first, left, column of dates and Sundays in the last. Software often starts with Sunday equals 0, which places Sundays in the left column of a monthly calendar page.
Accuracy.
The Gregorian calendar improves the approximation made by the Julian calendar by skipping 3 Julian leap days in every 400 years, giving an average year of 365.2425 mean solar days long. This approximation has an error of about 1 day per 3,300 years with respect to the mean tropical year. However, because of the precession of the equinoxes, the error with respect to the vernal equinox, which occurs, on average, 365.24237 days apart near 2000, is 1 day every 7,700 years. By any criterion, the Gregorian calendar is substantially more accurate than the 1 day in 128 years error of the Julian calendar, average year 365.25 days. In the 19th century, Sir John Herschel proposed a modification to the Gregorian calendar with 969 leap days every 4,000 years, instead of 970 leap days that the Gregorian calendar would insert over the same period. This would reduce the average year to 365.24225 days. Herschel's proposal would make the year 4000, and multiples thereof, common instead of leap. While this modification has often been proposed since, it has never been officially adopted. On timescales of thousands of years, the Gregorian calendar falls behind the astronomical seasons because the slowing down of the Earth's rotation makes each day slightly longer over time, see tidal acceleration and leap second, while the year maintains a more uniform duration. Balkowski reviewed mathematical models in the literature, and found that the results generally fall between a model by McCarthy and Babcock, and another by Stevenson and Morrison. If so, in the year 4000, the calendar will fall behind by at least 0.8 but less than 1.1 days. In the year 12,000 the calendar would fall behind by at least 8 but less than 12 days.
Calendar seasonal error.
This image shows the difference between the Gregorian calendar and the astronomical seasons. The y-axis is the date in June and the x-axis is Gregorian calendar years. Each point is the date and time of the June solstice on that particular year. The error shifts by about a quarter of a day per year. Centurial years are ordinary years, unless they are divisible by 400, in which case they are leap years. This causes a correction on years 1700, 1800, 1900, 2100, 2200, and 2300. For instance, these corrections cause December 23, 1903 to be the latest December solstice, and December 20, 2096 to be the earliest solstice, 2.25 days of variation compared with the seasonal event.
English names for year numbering system.
The Anno Domini, Latin for in the year of the Our Lord system of numbering years, in which the leap year rules are written, and which is generally used together with the Gregorian calendar, is also known in English as the Common Era. Years before the beginning of the era are known in English as before Christ, or before the Common Era. The corresponding abbreviations AD, CE, BC, and BCE are used. There is no year 0. AD 1 immediately follows 1 BC. Naturally, since Integravissimus was written in Latin, it does not mandate any English language nomenclature. 2 era names occur within the bull, Anno Incarnationis Dominici, in the year of the incarnation of the Lord for the year it was signed, and Anno a Nativitate Domini Nostri Jesu Christi, in the year from the Nativity of our Lord Jesus Christ for the year it was printed. Nevertheless, Anno Domini, and its inflections Anni Domini, and Annus Domini are used many times in the canons attached to the bull.
Proposed reforms.
The following are proposed reforms of the Gregorian calendar. Holocene calendar, International Fixed Calendar, also called the International Perpetual Calendar, World Calendar, World Season Calendar, Leap Week Calendars. Pax Calendar, Common Civil Calendar and Time, Symmetry 454, Hank Henry Permanent Calendar, Pax Calendar, Common Civil Calendar and Time, Symmetry 454, Hank Henry Permanent